So we're going to start learning target 5 today. And learning target 5 is all about using sum and difference identities. And before you freak out, the sum and difference identities do not have to be memorized. They're on the red pre-calculus formula sheet. And so all you have to do is know how to use them. So on the formula sheet, you'll see the following identities. There is a sum and difference identity for cosine. There's a sum and difference identity for sine, and also one for tangent. If you notice in all of them, there's a plus minus because they've combined the sum and difference identity into one. So you'll have to be able to split it apart. So I'm going to do that once, and then you could do that for sine and tangent on your own. But if we're trying to do the sum identity for cosine, that means we have cosine of two angles that are being added together. Whenever you use the sign in the top, you use the sign on the top everywhere else as well. So the sum of two angles is equal to cosine of the first times cosine of the second minus sine of the first times sine of the second. And then for the difference identity, you have cosine of one angle minus another. But now, since we're using the sign in the bottom of the plus minus, we're going to use the sign in the bottom of the plus minus. So cosine of one angle times cosine of the other plus sine of the first times sine of the second. The same rule applies for the sum and difference identities for sine and cosine. Whenever you're using the sign in the top of the plus minus, then you use them all the signs in the top. And if you're using the sign in the bottom of the plus minus, use all the signs in the bottom. So I will let you split those apart on your own. And we're going to be using cosine and tangent today. So tangent you can see is a little more complicated, but I'll have those for us on the next slide. So I'm going to do the first two examples today. They do take a little bit of work, and that's okay. But we're going to be using these identities to find the exact value of a trig function. Remember, exact value means we don't have decimals. Exact values are like what we see on the unit circle. Well, cosine of 165, 165 isn't on the unit circle, so I don't have that to use. So what we do is we use the identity, and we find two angles that are on the unit circle that we can add together in order to get 165 degrees. So we can find two angles to add or two angles to subtract. It doesn't really matter. So for my example, hopefully some of the first two angles that jump off at you from the unit circle are 135 and 30. But if you add those two together, you get 165. Well, I have an identity that says if I have cosine of two angles added together, then I should be able to find that value. So since we're adding, we're going to use the signs in the top. So this is equal to cosine of 135, because let's call this alpha and this beta, A and B, times the cosine of 30 minus the sine of 135 times the sine of 30, okay? So then we're going to go through and we're going to just substitute in those unit circle values. So looking at the unit circle, the cosine of 135 degrees is negative square root of 2 over 2. Cosine of 30 is the square root of 3 over 2. Sine of 135 is the square root of 2 over 2. And the sine of 30 is 1/2. So this one doesn't look so bad. We're just going to multiply fractions and simplify. So negative square root of 2 times times positive square root of 3 is negative square root of 6. And we just multiply the numbers under the radical. And that's over 4. Minus the square root of 2 times 1 is the square root of 2 over 4. And then since we're looking for a nice, clean, exact value, we just combine this into one fraction. And that is the cosine of 165 degrees. So we had our starting point. We split that into two angles we could get from the unit circle. And then we used the identities to be able to simplify and find a nice exact answer. So again, you're just using those identities. They're almost like formulas. The next example is tangent of pi over 12. Now, pi over 12 is a radian measure, but pi over 12 is also a fraction, so you would have to find two fractions you can add or subtract to get pi over 12. I'm just going to be honest, most of you guys aren't awesome with fractions, so what you can do is multiply by 180 over pi, like we did in the last unit, and we can change this to a degree measure, and that's just fine. So now I have tangent of 15 degrees, so I need to find two angles on the unit circle that I can add or subtract to get 15. You're not going to be able to add them, so you're going to have to subtract. And here I want to make a quick point. All right, tangent already is a bigger identity. It has a fraction. So if you go to the unit circle, so we're going to look at that real fast. Here are the tangent values for pi over 6, pi over 4, and pi over 3. Pi over 6 is the square root of 3 over 3. Pi over 4 is 1, and pi over 3 is square root of 3. Then these can be translated around the unit circle. Tangent is already a fraction, like the identity for sum and difference. So if at all possible, you may want to avoid using angles that have the square root of 3 over 3, if at all possible, because then you're going to have a fraction in the numerator, a fraction in the denominator, and it just gets a little bit more messy. So if at all possible, if you can avoid these angles when you're doing tangent, it'll probably save you some time. All right, so remember, we're trying to find the tangent of 15 degrees, and so it's really easy to say, oh, 45 minus 30, that's 15 degrees. But then I'd be using this fractional measure. So I'm going to use 60 minus 45 instead, because then I don't have that fraction. So I'm trying to save you time and save you struggle. You just think through those tangent values first. So I'm going to have tangent of 60 degrees minus the tangent of 45 degrees. So to use identity, is split that apart. We're using a subtraction, so a difference identity. So we need to use all the signs on the bottom. And so we get, again, this is alpha and this is beta. So we have tangent of 60 degrees minus tangent of 45 degrees all over 1 plus tangent of 60 degrees times tangent of 45 degrees. So we're going to go back and substitute those values in. Tangent of 60 degrees is the square root of 3. Tangent of 45 is 1. And then in the denominator, we have the square root of 3 times 1. We all know that the square root of 3 times 1 is just the square root of 3, so I'm going to go ahead and erase that because it's such simplified. Now we can't have a radical in the denominator, so we're going to use some Algebra 2 logic and use a conjugate. So we're using the denominator with an opposite sign, and that causes us to FOIL. So the square root of 3 times 1 is the square root of 3. The square root of 3 times negative square root of 3 is negative 3. Remember, you multiply two square roots. You multiply the numbers underneath, so you get the square root of 9. Negative 1 times 1 is negative 1. And negative 1 times the negative square root of 3 is positive square root of 3. Just think about how much more difficult this would be if you had a fractional square root of 3 over 3. In the denominator, you have 1 times 1. 1 times negative square root of 3. Square root of 3 times 1. And square root of 3 times negative square root of 3 is negative 3. So now we're just going to simplify. The square root of 3 plus the square root of 3 is 2 square roots of 3. And then negative 3 minus 1 is negative 4. In the denominator, negative square root of 3 plus square root of 3 cancel out. And so you're left with 1 minus 3, and that's negative 2. That's the same as if you split this into two separate fractions. So all I'm going to do is simplify. Since I have an even number in both of those fractions, I get negative square root of 3, that's 2 divided by negative 2 is negative 1. And negative 4 divided by negative 2 is positive 2. So there's my nice and neat tangent value. Again, think of all the extra steps we have to do if we had the square root of 3 over 3 instead. I'm trying to save you some time. I'm actually not going to do the last example, but I want to give you a few pointers here. So first of all, you have to find an angle coterminal because we're trying to find 795 degrees. We can't do that by adding and subtracting things on the unit circle. So remember, coterminal means between 0 and 360. And so what ends up happening is we end up getting 75 degrees as a coterminal angle. We also don't have an identity for secant, so you're going to have to use the cosine identity. Again, you can use sum or difference to get 75 degrees. And since we're actually trying to find secant, at the end you'll have to find the reciprocal of the answer to get secant. That'll give you secant of 75 degrees. So a few extra steps, but still the same process. We did one just like that with the cosine of 165. This is just the first half of Learning Target 5. Learning Target 5 is very algebra heavy. But again, you have these identities that you're going to be using. So at least you have a starting point. It's not so confusing with Learning Target 4.